0 is in the interval of plausible values, it is plausible that there is no difference in the effectiveness of breath versus stool samples in having this dog detect cancer. 3.105 Average tip for a waitress. Data 2.12 on page 119 describes information from a sample of 157 restaurant bills collected at the First Crush Bistro. The data is available in Restaurant Tips. Create a bootstrap distribution using this data and find and interpret a 95% confidence interval for the average tip left at this restaurant. Find the confidence interval two ways, using the standard error and using percentiles. Compare your results. StatisticsHomeworkHelper.com. X plus or minus 2 SE 3.85 plus or minus 2, 0.19, 3.85 plus or minus 0.38 3.47 to 4.23. For this bootstrap distribution, the 95% confidence interval using the 2.5 percentile and solution using one bootstrap distribution, as shown below, the standard error is SE equals 0.19. The mean tip from the original sample is X equals 3.85, so a 95% confidence interval using the standard error is. For this bootstrap distribution, the 95% confidence interval using the 2.5 percentile and 97.5 percentile is 3.47 to 4.23. We see that the results, rounding to 2 decimal places, are the same. We are 95% confident that the average tip left at this restaurant is between $3.47 and $4.23. 3.116 Small sample size and outliers. As we have seen, bootstrap distributions are generally symmetric and bell-shaped and centered at the value of the original sample statistic. However, strange things can happen when the sample size is small and there is an outlier present. Use StatKey or other technology to create a bootstrap distribution for the standard deviation based on the following data: 8, 10, 7, 12, 13, 8, 10, 50. StatisticsHomeworkHelper.com. Clusters of dots represent the number of times the outlier is included in the bootstrap sample. Describe the shape of the distribution. Is it appropriate to construct a confidence interval from this distribution? Explain why the distribution might have the shape it does. Solution: the bootstrap distribution for the standard deviations, shown below, has at least 4 completely separate clusters of dots. It is not at all symmetric and bell-shaped, so it would not be appropriate to use this bootstrap distribution to find a confidence interval for the standard deviation. The clusters of dots represent the number of times the outlier is included in the bootstrap sample, with the cluster on the left containing statistics from samples in which the outlier was not included, the next one containing statistics from samples that included the outlier once, the next one containing statistics from samples that included the outlier twice, and so on. 4.17 Beer and mosquitoes. Does consuming beer attract mosquitoes? A study done in Burkina Faso, Africa, about the spread of malaria investigated the connection between beer consumption and mosquito attraction. In the experiment, 25 volunteers consumed a liter of beer while 18 volunteers consumed a liter of water. The volunteers were assigned to the 2 groups randomly. The attractiveness to mosquitoes of each volunteer was tested twice, before the beer or water and after. Mosquitoes were released and caught in traps as they approached the volunteers. StatisticsHomeworkHelper.com. For the beer group, the total number of mosquitoes caught in the traps before consumption was 434 and the total was 590 after consumption. For the water group, the total was 337 before and 345 after. A. Define the relevant parameters and state the null and alternative hypotheses for a test to see if, after consumption, the average number of mosquitoes is higher for the volunteers who drank beer. B. Compute the average number of mosquitoes per volunteer before consumption for each group and compare the results. Are the 2 sampled means different? Do you expect that this difference is just the result of random chance? Chance? C. Compute the average number of mosquitoes per volunteer after consumption for each group and compare the results. Are the two sampled means different? Do you expect that this difference is just the result of random chance? D. If the difference in part, C, is unlikely to happen by random chance, what can we conclude about beer consumption and mosquitoes? E. If the difference in part, C, is statistically significant, do we have evidence that beer consumption increases mosquito attraction? Why or why not? Solution: A. We define B to be the mean number of mosquitoes attracted after drinking beer and W to be the mean number of mosquitoes attracted after drinking water. The hypotheses are H0, B equals W Ha, BW. B. The sample mean number of mosquitoes attracted per participant before consumption for the beer group is 434 divided by 25 is equal to 17.36 and is 337 divided by 18 is equal to 18.72 for the water group. These sample means are statisticshomeworkhelper.com. Slightly different, but the small difference could be attributed